Today we're doing medium problem 1043 partition array for maximum sum. Essentially we need to partition into k continuous subarrays, and then with each subarrays we change all elements to maximum of that subarray and then take sum of that, and we're supposed to find maximum. Answer feeds into 32-bit integer. Question is, what are the constraints? So 500, so I mean, okay, let's say we are in this position and we want to do like, I don't know. Okay, let's say we have whole array and we want to create, right? So we can, first partition can be this, and then we have to solve the same sub problem for this k minus 1, right? And for that we can try this, and k is equal to 1, right? And if k is 1, you just get the prefix maximum, or who cares what, right? So basically we want to do a DP like that. And then essentially what we are doing is we have state is we compute prefix maximums, right? Or no, because for given ik, right, how many, what can we try? Well, we only try k minus 1 for each of these values, or for like whatever, k up to 0, k minus whatever, right? Something like that. So I guess that will be quadratic. dp do 0 for j in range, k plus 1 for I in range, n plus 1, why not? And then for I in range 1, n plus 1, and then let's say maybe recursion will be easier to start off with. Def dp I current k, then if current k1 return max, can do like pref of I plus 1 prefix maximum times I plus 1 pref max 0 times n 0 array 0 pref max I pref max minus 1 so we do prefix maximum, and then we do for j in range I up to what? Well, if 1, then we want to go to current k to 0, but also including the zeros, or current k minus 2. Okay, and then minus 1 index here, and then basically we maintain like the max is num xi, right? And then we want to do ans is 0, right? And then ans is max ans, and then it's like maximum times I minus j plus dp jk minus 1, and then return ans, and then we call dp and minus 1k and return we return that actually, and then here I have like current k, so I need to do this, and then nums is not defined. Okay, who cares? Still nums is not defined. Okay, who cares? Oh, I'm not updating, so max nums j. Let's see. What? How is it possible? How is what? One, okay, so that case works. 84 is supposed to be 83, that's great. Not sure how you got that. How you got 90, bro? What the hell? Print JIK ans. Okay, so let's say we are at the very end. What the hell? K is less than or equal to array length. Okay. That's interesting. Another painful debugging session incoming. I can already smell it. So we are doing what? 1, 2, 3, 4, 5, 6 with 3, right? Then 5 with 2 and 4 with 1. Then we are doing 0, 1, 3 with 1, 2 with 1, 1 with 1. Because, okay, let's say we have like because if it's 2, right, then I mean theoretically if you want to have the last one you should go like this or like this or like this. I have no clue, bro. What the hell? Print I current k and this. So for what? Give me list, bro. So with 3 left, I want my last index to be, because that's correct, I think, because we can do like, okay, let's say we cut here and then we can do 1 here. Okay, that's fair. Okay, so I guess that works, but I'm still interested in knowing how we got 90. Print I current k answer, print current k pref max I times. Okay, so 6, 3 was 90. 1, 2 is 16, that's fair. 2 is 37 somehow out of this. Okay, that's fair. 3 is 63. How do you do that? That's already wrong. Hmm. 4 2. If I for and max so far, no, j max I minus j and then dpj current k minus 1. Okay, so right here, let's say we took 4. What? How is max just 2 at 3? Okay. I mean, I don't quite understand why is maximum, because if that's I is 4, okay. (27 plus 30) still 57. So how you do that? 45 plus 18, I guess that makes sense. Then you can do 45 plus, or no, how can you do 80 out of 0, 1, 2, 3, 4, 5 here? 27, no. I mean, in 2, I mean, you for sure wanna take this. How do you even get 80 out of 0, 1, 2, 3, 4, 5? Okay. How you do 90 is beyond me, bro. This is 54 from here into well, somehow 5 to do 80, so I have to. Well. 0, 1, 2, 3, 4, so that's 5 times 15 is also, you can do 80 like that. What? 30, 60, 75. Oh, of length and most K. Oh my days, that's 10 times simpler. What the hell? Hell nah, bro. Holy. Okay, that's even easier. I mean, that's like that. We can skip out on this. Then we can skip out on this. And then we don't have to do this. And then we skip this. Then we don't need prefix sums. And then if I return 0, 105, that's crazy. But I need no. Range I minus 1. Let's see. Okay, so last 3 indices. That's the problem. So we need to do like max of this and minus 1. No, we need to do like len is 1 while I is over len, then max times len I minus len. Couldn't they do smaller examples, bruh? That is ridiculous. Okay, now it works. Okay, all my days football is already running for 11 minutes. I'm so late. Okay, so what do we call this? DP. Let's do like ONK, right? Intuition. At each point we can find the we can make the answer by putting last 1, 2, blah 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 k elements into the first subarray. If we go from the back, we can count the subarrays maximum and multiply it by the current length. Then we just have to solve the same problem on the remaining prefix of the input approach. DPI is, or let DPI be the maximum profit first from nums or like array I, then DPI is max of max. Let's do like max over all j max of nums ji, or like, is it like array times I minus j plus dp j. Something like this over all j such that base case is dp I0 for I0 O and K, since we do OK work per each of the ON states. Memory ON, since we have ON states. Okay, I mean DP is not difficult, especially for such a simple medium problem. Anyways, I'm going eating and watching the match, so goodbye.